Hello, my name's Ira, and my voice is still not very happy with me, so I guess we all have to suffer with it, at least for a bit. So, I talked about this project I made in the last video. Just wanted to explain a little bit about how it works, just so you can appreciate it just as much as I do. And I appreciate it. So, we start off in the main function, the main file, right in here. And I'll just step through how the code will run. So, the main function is started. It's the first thing that runs. And first you have a few instantiations. You get the input of how, well, I talked about the settings, configurations for how you want it to look. The program gets those from the user, loads them into the actual, well, it's a class that holds all the information for things, so it loads that information into a class, generates an image, and then a lot of this is just logging and just not very important. What's important is the generate and populate function. So, the generate and populate class, and then the procedural generation function. So if we hop over to that file, then we have the generate and populate class and procedural generation function. What it does is it generates a matrix of what each block is going to hold. Now, working with blocks instead of trying to do everything all at once, it's able to make it so that, well, it's just easier. If there's an error in one of the blocks, you can go to that specific block and work out what's causing problems. It just makes it easier, and it's a bit easier for me to conceptualize. Imagining the entire map as a matrix, a two-dimensional matrix or an array. And that's what we do here. Instantiate it. Then we have a 2D for loop. This part, it's only kind of important. It's to generate borders around all of it, and I don't dislike it enough to take it out, but I don't like it enough to leave it in, so it's just there. But then we have logic for what elements can be built. And this is the part that it took a lot of conceptualizing how to get it to work. So, yeah, this block, this is one of the most important parts of this entire thing, because this is the part that decides what each element is going to be, whether it be a ceiling, or, not a ceiling, whether it be a floor, or a tree, or a wall, or a door. This block decides what it's going to be. So, it runs through all of the blocks in that matrix, all the blocks that can be generated. In the example I gave in the last video, it was a 20 by 20 matrix. So it ran through 20 by 20 blocks. So 400 elements. 400 elements. 400 blocks. Around the borders, then around the borders, it just sort of... Okay, the code isn't that pretty right here, but for the borders, it just randomly selects either a floor or a tree on the first pass. Then, let's see, when it's not on the border, so that's what these little if statements are for, making sure that's not on the border. Then it's able to load what the ceiling, floor, left, and right blocks are. Now, why is that important? Because if we go to the building rules file, this is what it looks like. When we build this element, that block, it looks at the ceiling, the left block, the right block, and the block below it, the floor. And it runs through these different rules for what can and cannot be built in these cases. So, say you have a wall on the ceiling. The ceiling is a wall, and its configuration is a corner configuration. In that case, all of these dictionaries in here that do not have a negative or a dash in front of it, these are allowed configurations. So you can build a vertical wall, a vertical door, or a corner wall if the ceiling is a corner wall. These three, even if, say, a floor or a horizontal wall or a horizontal door is built, is allowed by any of the other blocks, whether it be left, right, or floor, these dictionaries that have the negative sign in front of it, and these things are dictionaries. In Python, a dictionary is a tuple that has the key and the value. It's just something to work with. Yeah. But the point is that if it has this negative sign in front of it, then no matter if that type of element, so no matter if a floor is allowed in any other of the positions, it's on the disallow list, so it will be removed from the allowed elements list. And we have a little bit of trying to describe how in the world to look at these rules. I went through a handful of different ways trying to figure out how I would get rules to work. I really didn't want to have to do this type of rule set, where I would have to have allow and disallow lists for every single type of block. I didn't want to do that, but trying to build more fuzzy or more open-ended rule sets, it just looked like it would be more and more work the more I thought about it. So, doing it this way is what I decided on. Let's see. It's not this one, it's generate and populate. So it's able to run through those rules I just showed you, and, well, logic for the ceiling, and the left, and the right, all these different positions. It gets the rules for what can be built there. Then it removes those rules that are not allowed. So you remember these rules that have the negative or the dash in front of them? Just to make it easier on myself, I put the disallowed rules at the end of each of these lists. But they can be in literally any position. It just makes it easier for me to put them at the bottom. But it removes those elements from the list. So if we go to the disallow rules, it was at this point when I was programming it that I was just sick and tired and wanted to get the stupid thing to work, so you'll notice there's a lot of logging calls in it, because it just kept not working for me until finally I made a little breakthrough and it started working. Just like I thought it was supposed to. But this block of code, it's not the prettiest. Actually, a lot of it isn't the prettiest. I could have done better, but I was just tired of working on it and throwing time into this thing, and just wanted to get it to work. So, in the disallow rules function, it goes through the possible elements, and if that dash is found in front of it, then it removes that element from the list, adds it to a remove list, and then removes all of those elements from the possible elements list, and returns it. So now, the possible options, the possible next elements that can be built, all of the disallowed elements have been removed from it. Next, we load the wait list. How likely every type of block is going to be generated. I put all these static variables, or things, into this other file. I wanted to keep them all together, so I kept them in the statics.py file. Is that the best? Not exactly, but, well, it just made it easier for me, so I knew where everything was. But loads each of those, like my variable names. Thingy. I was losing creativity at this point, but it goes through each of these: wall, door, tree, floor, and adds both the key and the value into their own separate lists. Then that is loaded into the randomized choice function. So I'm using the random library, which it's an amazing thing, and I don't use it all that often because I don't use random number generations all that often. But the choices, starts with a P. Okay, can't think of the word, but the random.choices function, you're able to load a list of different options, then you're able to load the weight. Problem is, the return is as a list. So yeah, what I had to do was take only one element in that list. I suppose you could return multiple, and then just only look at that first element. And then a handful of just funny little things trying to work with dictionaries, because they can be a tad bit finicky sometimes. Right here, you remember that continuous borders option and the, what's it called? Configurations for this? Right here, if you want it to be continuous. Well, that runs this code. If you want it to be continuous, then this is going to put borders at each of the borders. So let's look at the example that we generated. Solid borders at the corners and the sides. So, just a fun little thing there. Then, I suppose I might want to talk about this logging. The logging class that I just made. Let's see. Where is it? Where is logging? There we go. Logging and output. Now, I come from... Python isn't exactly my first language, and I am just so used... Wait a minute, I'm thinking of the wrong one. Okay, so, sorry, scratch that. But I'm sure we can all understand you have to put a lot of print statements, trying to figure out what's working, what's not, a lot of troubleshooting, error checking, etc. Well, problem is, having 50,000 print statements, it takes a very long time to load, because your computer has to open the standard output file, load the text into it, close the file. It has to do a lot of operations. It's the slow point. It's a bottleneck. If you have a large program that's doing a lot of print functions. So, I have this logging class that what it does is it just, you're able to have, currently, I just have 3 different types of returns, types of outputs. You have logs, you have errors, and you have says. Now, logs, this is just for troubleshooting. In fact, when you instantiate the logging class, instantiate it with the true or false. True, and these log returns, log outputs, will be returned. They're going to be generated. If you instantiate it with false, then they're not going to be returned. It's just going to not run it. Also, because print output returns are just so slow, I have it run on its own thread, so that your program can still run without slowing down as much. It's not exactly fast, but could be a lot worse. Let's see. Back to where we were. Possible next elements, you have the wait list. Then you generate an element using the options that are predefined. So, if it's a wall or a, whatever. So, elements are, well, it's an object. It just makes it easier to work with, so I gave them their own class, and because I am not exactly native to Python, I just had to put getters and setters. I mean, it's muscle memory, it's just the correct order of things. Do I ever use them in this entire program? No. Okay, I do use the getters, but that's it. You generate a new configuration for it. So you generate a new element, you generate a configuration for it, and then you load that element into the block matrix. Super fancy. So in this example that I ran at the very start, it's a 20 by 20. Okay, it's a 20 by 20. There's configurations. 20 by 20, which means that there's 400 blocks, because it's a... You get the idea. It would take forever to type it out. But there's 400 blocks in this block matrix. So it loads that element the element object into those. And then it runs the actual populate function. This is the part where it actually converts that element object into an actual bitmap. This is where it actually generates a thing. So we run through the entire block matrix, so the 20 by 20 in this case, and it loads whatever type of element it is. If it's a wall, then it loads a wall. If it's a floor, it loads a floor. You get the idea. And then, actually, let's look into each of these. So the filled area, that is... You remember how I said that's divided up into blocks? Well, that's the block. So, filled area. These are all passed into the creation class. So, okay, walls are kind of complicated. Let's go to floors. Yeah, that's a door. Where's a floor? There's a floor. Okay. Okay, so these are the simplest ones. But the floor, you pass in what type of floor it is. So that goes back to the background color. If it's stone or wood or forest, or if it's a wet floor, you get the idea. And then it generates that block. For floor, I kind of cheated and just have it fill that area, and then it returns that. So then let's just look at the fill. Def. There we go. So it just generates an image for that block, loads it, and then populates that image with a fuzzed coloring. So let's look at this block right here. You'll notice that they're not all the same color. It's not just one solid color all the way across. That is because I have it fuzzing the colors, just to make it seem less straight-edged, more organic. So it runs a color through that fuzzing function. It's at the very top of this class, and it just fuzzes the coloring just a little bit, plus or minus 15. It fuzzes that color, and then loads it into each of the different blocks, or pixels in that block. Block size? Well, they're all square blocks, so don't need to have in block X or block Y. It's just square. So basically, it creates a bitmap pixel array with each of the different colors. Trees, it's pretty much the same thing except that you fill it with whatever type of material the background is, whether it's wood or stone or whatever, and then you just create a circle. That was the wrong thing. Sorry, I'm just so used to doing Alt-Tab. So if we look for, oh, there's a tree. It's just a green circle inside of a square. Kind of boring. I could have made it to have it more interesting, but this is all it is right now. You have a circle. Decorations, well, you have a randomization based on weights for what kind of decoration, and I suppose it could look a little bit prettier, but you can have plants or chests, and it's just laws and rules for how to generate the visual for it. Doors, etc. So each of these items would have an orientation. Vertical and horizontal orientations are important and different, so I had to build in rules for each of those. And it populates that little block using, well, the creation class. That populated block is then passed into this little X by Y matrix. Double for loop, nested for loop, that's what it's called. And it actually populates the entire image thing. So pixels, that's like this little part of it, and they're all slapped together. Once every single block has been filled, has been generated, then it's returned. And IMG is that full, complete image. We stop the clock, we end the stopwatch, and tell you how long it took, show you the image, and save it. Now, the default image name I have, it's just MapX, because, well, no particular reason, but I just saved that. And right here, I just have a couple of links for references that I used. Important. These are kind of where the entire project started. Using these two references for how to get a bitmap. And that kind of expanded from there. But, yeah. That is my map, D&D Map Generator. So let's just run it again, because this thing's kind of fun. So let's do a 50 by 40. And then how many iterations? Let's just say 10. Make it interesting. And then have a stone. Then number of pixels per 5 by 5. Let's just do 50. And then continuous. Yes. So, for some of these larger things, it can take some time. So, it can take some time to run through the actual generation, and it can take some time to actually load it, generate the image. So, this one's actually going pretty fast, which is nice. And looks like we're already finished. Took 25 seconds, and there we go. Now, if I was a player and my DM threw this at me, then I would be pretty ticked off because that thing's massive. But I suppose it's not so much something I'm going to use in an actual D&D session, but it was a really fun project with progressive image generation, working with bitmaps, progressive generation rules. It was really neat. So, sorry for making you suffer with listening to my really scratchy and not very happy voice, but thanks for watching. See you.